Hello, good day viewers. In today's tutorial we are going to see the ASCII code. As you can see from the table shown below, we have the characters and its ASCII code, from art to capital letters and small letters and the bracket and rest hyphen and rest. So all we have is value. So therefore the question is that using the ASCII table shown below, convert the word below to binary. So as we all know that ASCII code, it has the binary bit of 7. It has binary bit of 7, which is 2 to the power of n minus 1, as we all know. So therefore 2 to the power, because we said its binary bit which is 7, 2 to the power of 7 minus 1, it will be equals to what? 2 to the power of 6. 2 to the power of 6 is the same thing as what? 64. So this is therefore it means that the binary placement, the placement of a binary, the ASCII code placement, it is what? It is 64. It means that we have 64, we have 32, we have 16, and therefore we have 8, we have 4, we have 2, we have 1. 1, 2, 3, 4, 5, 6, 7. So therefore this is what we mean. The placement of ASCII code in binary, which is what? The placement which is 64, and therefore the binary bit which is what? 7. So therefore how can we convert this word below to what? To binary. So let's say this is what? Let's say this is letters, and let's say this is what? This is decimal, because we are going to pick the decimal first, and therefore the decimal we have to convert them to what? To binary. So therefore let's say this is what? This is the binary. So therefore let's say we have letters, let's say we have the decimal here, decimal, and let's say we have what? We have the binary. So we have letter V, we have L, we have U, and therefore we have what? We have E. And therefore we have to check capital letter V, which is what? Which is 66. And therefore small letter L, which is what? Small letter L, which is 108. This corresponds to this corresponds to this, and this corresponds to this. So therefore the small letter U corresponds to 117, as you can see, and therefore the small letter E corresponds to 101. So therefore let me pick my calculator. So therefore the next thing that we are going to do, we have to convert this 66 to what? 66 to binary. So therefore some of you might use this, let's say 2 and what? 66, and pick their remainders. So therefore this will waste your time if you're dealing with, if it comes to your exam, you will waste your time. So now I will give you the easy way. The easy way is that I determine this placement of what? Of the ASCII code binary, which is 64, as I said, which is 64, 32, 16, 8, 4, 2, and 1. So I have to say what? I have 64, I have 32, I have 16, I have 8, I have 4, I have 2, I have 1. Someone might ask, what should I going to do with this? So wait and see. You have to concentrate. The next thing is that, let me say I have this. Let's say I have this. I separate this, and also. So therefore, I have to take a look to the decimal first, to the 66. What numbers should I going to add to get 66? You must to include 4. So the number that you include, you have to put 1. The number that you don't include it will be 0. So therefore if I say 64 plus something, yes, it might give me 0, but 64 plus 32, it will not give me what? It will not give me the 66. Sorry, 64 plus 32. It will give me more than my decimal that I'm looking for. But 64 plus, let's say 64 plus 2. Yes, 64 plus 2, it will give me 66. This is 64, this is 2, it will give me 6 and 6. So therefore, I didn't include this, I didn't include it, but I include these 2. So these 2 should now become 1, but all the rest will be 0. I hope you get this point. The next is that, what number should I add to give me 108? I must include this 64. Yes, I must include it. The next is that I must include this this 32. Okay, sorry, I put 64. If I include 64, I'll get 1. And I must include 32 because 64 plus 32, it will give me 96. So I must include it. So therefore, 96. If I say 96 plus 16, will it give me 108? It wouldn't give me. But if I say 96 plus this, so it wouldn't give me 16. If I add 96 by 16, it wouldn't give me 108. So therefore, it becomes 0. If I say 96 plus 8, let's check 96 plus 8. Yes, it gives me 104. So 104, it is very close. So therefore, this is included. So if I say that 104 plus 4, 108, so therefore this will be included and the rest will be what? Will be 0 because I didn't include them. I have to get this point. The next is that I must include this, I must include this. I will get 96. If I say 96 plus 16, what should I going to get? I'll get 112. Yes, I must include this. So I have 112. What am I looking for? I'm looking for 5. I will not include this. Shall I include this? Yes. 112 plus what? Plus 4. 116. I will not include 2, but I will include 1. 116 plus 1, 117. I have to get this point. The next thing is that I'm going to find 101, and I must include 64. So therefore, it will be this will be 1, and therefore I must include it because 64 plus 32, it will give me 96. If I say 96 plus 16, it will not give me this 101, so it will become 0. So if I say 96 plus 8, what shall I going to get? If I add 4 here, it will give me 100. If I add the rest 4, it will be more than 101, so therefore it also becomes 0. But if I add 96 plus 4, it will give me 100, so therefore it is less. So I will say 1. 4 can go. So therefore, what if I say 100 plus 2? It will give me 102, and I'm looking for 101. So this will be 0. And if I say now 100 plus 1, 1 can go. So I'll put 1. I have to get this point. So therefore, as you can see, this is the very easy way to what? To convert decimal to binary. So I'm advising you in your exam to use this way that I show you. The next thing is that you have to say, so therefore, blue to binary, B is the same thing as 100010, and therefore L is the same thing as what? 110110, and U stands for 111001, and the E, small letter E, which is what? 11001001. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, as I said. And therefore 64 8, okay, 64 32 16 8 4 2 1 1 2 3 4 5 6 7, 7-digit binary. So therefore this is the end of this question because we convert this blue to binary. So therefore let's see the second question. The second question says that using the ASCII table shown below, convert the following binary coded message into a word. In the first question, we convert word to binary. So here we're going to convert what? Binary to what? So therefore, as we all know, we have 64, we have 32, we have 16, we have 8, we have 4, we have 2, we have 1. So you have to keep this thing down. I will say 1 0 0 1 1 0 0. It will give me what? So, and the next I have 1 1 0 0 1 0 1, and I have 1 1 0 1 1 0 1, and therefore I have 1 1 0 1 1 1 1, again 1 1 0 1110. So here is the easiest way that you will find what? You find the decimal. You will first find the decimal of what? Of this binary, so that you can check and see the letter. So what are we going to make? Let's work it out and see. Feel free to pause the video so that you can try it. This is a practice problem. So therefore, how can we first find the decimal of this first binary? We all know that this is 0. This will get away of this. We'll get away of this 0. And also we get away of this 0. We get away of this 0. So we are going to deal with 1, 1, and 1. So I have 64. 64 plus 8 plus what? Plus 4. With 8 plus 4, it will give me what? 76. So the next thing is that I will get away of what? I will get away of this, and also I will what? I will get away of this. I will get away of this 0. So what I have 64. 64 plus I have 32. Then I have 4. Then I have 1. Plus 4 plus what? Plus 1. So therefore I have what? I have 101. So the next is that I will get away of this. I will get away of this. So I have 64 plus 32, which is 96. Which is 96. 96 plus what? 8 plus 4. 8 plus 4 plus what? Plus 1. So I have 109. 109. So the next thing I will get away of only this. I'll get away of only that. So I have 64 plus 32. 64 plus 32, which is 96. And 96 plus what? 4 plus 8, which is 12. Plus 12. Plus what? 2 plus 1, which is 3. Plus 3. So I'll get what? 111. The next is that I will get away of this. I will get away of this because they are zeros. Anything that I get away of this, because I will multiply it by what? I will say 0 multiplied by that number. So therefore it will automatically give me 0. So therefore I have this plus this. It will give me 96 plus what? Plus 8 plus 4, which is 12. Plus what? Plus 2. So it will give me what? 110. So I have to check it. Check to my what? ASCII and see what the values, and I will check my characters. 76. What is 76? 76 is L, capital L. And therefore, let's see for 101. Where is 101? Yes, this is 101. I have small letter what? Small letter E. And therefore, I have 109. Where is 109? 109. Yes, 109. I have small letter M. And therefore, I have 1111. 111, I have what? I have O. Small letter O. And 110. 110, I have N. Wow. So this is lemon. So therefore, this is what? Lemon. So as you can see, this turned back to this. So at the end, I will say that this binary is the same thing as capital L. This binary is the same thing as small letter E. This one is the same thing as small letter M, small letter O, and therefore small letter N. So therefore it gives me lemon. So this is all I have for you in ASCII codes. Kindly consider subscribing and do share to your learning colleagues. Thanks you for watching. Have a nice day.